All right, everybody. So today you're going to be taking your Unit 7 test. And in order to get you ready for it, you were trying to warm up that had a couple problems very similar to the test. In fact, once you see the test, you'll realize that it's almost exact. Your test today has 17 questions. Remember that the first 13 are kind of like multiple choice, but the last four are going to be on paper only, and you don't have to type anything in for those onto the computer for that. Now, with that said, you should have already given these problems a try. So now I'm going to show you so that you can check your answers and we can use this as a review for the test right before you take it. So let's begin. Again, your word wall should be ready. And of course, Desmos is what you're going to be using, and it should already open up. As soon as you open your Chromebook, Desmos will pop up for you. So with that said, here we go. It says, which one of the following is a correct equation? Now, when I look at these problems, I notice that it says cosine, sine, and cosine again. All right, well, that just means one thing. We are definitely working with our friend SOHCAHTOA for this problem. And if we're going to be working with our friend SOHCAHTOA, then we're going to label for SOHCAHTOA. And if you are still struggling with the labeling for some reason, remember we have a picture here. Let's get that good word wall going here. This is the one that helps me with the labeling. In fact, it looks exactly like this picture. Check that out. There's the angle, which means this is the adjacent, this is the opposite, and then here's the height. But of course, when we look at that very carefully, we notice that there is nothing here with the letter O. So anything with an O is gone. There is the winning trig function, which means we're going to be using C for cosine. And if that's the case, then so long letter B and letter C. They're using the wrong trig function to begin with. I'm supposed to be using sine, and so here's my setup. Sorry, cosine, we said. So here's our setup for CAH. It says write the cosine, write the angle, well, it's 39, is equal to a fraction, and it says adjacent on top, so there goes the x, hypotenuse at the bottom, there goes the 9, and if you notice, we don't even have to solve it. All they wanted us to do was to pick the correct equation. But if you rush through this, you may accidentally pick the wrong one. That's why order is very important. Now, when we get to number 2, now number 2 says find the length of a diagonal of a square with a side length of 12. Perfect. They said this thing is a square. There's your hint. Now I know where to look in my word wall. So I can even copy the picture that I see right there. It says draw a diagram. Well, then I'm going to draw a square. And then the great thing about drawing a square is that we know that all the sides are equal to each other. So I'll make this little mark right here. They already said every side is 12. Then I get to put a 12 here, 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 and here. So they're all 12s. But that wasn't the question, right? This is not perimeter or anything like that. They said, what is the length of a diagonal? Well, this right here. This is a diagonal. And notice what they have here. If they want me to find that diagonal, well, according to what it says here in my word wall, if this is 1, 1, 1, 1, my diagonal is the same number 1 with the radical 2 next to it. Well, if this is 12, 12, 12, 12, then this is the same 12 with the radical 2 next to it. And look at that. That's our answer. 12 radical 2. Again, not meant to be difficult, but the word wall's there to guide you. You can't freeze up. Moving right along. Number 3, again, you're just checking your answers. I don't even want you writing. I need you just looking. So for number 3, it says B is 22 radical 3. Okay, so there's B. We put it where it belongs. But the thing that stands out to me in this problem is the fact that this is a 30-degree angle. And if this is a 30-degree angle, well, I already know where to look in my word wall. Here comes that 30, 60, 90 again. And so when I'm looking at that 30, 60, 90, look at what it says. I should be labeling my small, medium, and large. It's even in the same order as it is here. Small, medium, large. And now I'm going to bring in my formula. So according to this, my formula for small, medium, large is K radical 3, and 2K. Now, the reason we bring this formula in, and again, we'll look at what they want shortly. There, my formula is ready. The only side they gave me was the medium, 22 radical 3. And so all I have to do is figure out what the K value, that constant value is. Well, it's right there. See, they both say radical 3, but the K is 22. So anywhere I see a K, I'm going to write 22. So there's a K. I'm going to put a 22 right there. Now, this one has a 2, but it's right next to it. Well, there goes that 22 again. But that one does require a little bit of work. 2 times 22, I would really call that a 44. So now I'm just going to bring that information back into my picture. I already have everything. You might as well bring it in. The small is 22. The large is 44. But be careful. They didn't ask you to find all the answers. When you read carefully, it says, what is the value of just the letter C? Well, here's the letter C, which is why my answer is 44. This was not choose all that apply. You were supposed to pick just one answer. All right. Number 4. When we look at number 4 now, it's asking, what is the measurement of angle A? Well, remember, there's only one thing in math that helps me find the measure of an angle when I have right triangles. And that, once again, is our friend SOHCAHTOA. And if I'm going to bring in SOHCAHTOA into the mix, once again, it all begins with labeling, which is, again, the struggle for some there. All I have to do is label, and look, I'm working with angle A, so that's this one up here, so I mark it. And because I'm marking that top one, again, we're trying to help you out. Look at that, adjacent, opposite, and the height, the hypotenuse. But remember, when you're working with SOHCAHTOA, you always have to work with two sides. And I understand the concern here. You look at it and you might tell yourself, yeah, but they gave me 3 numbers. Okay, that doesn't matter. When you're working with SOHCAHTOA and trigonometry, you only need 2. So because you have all 3, this is a free-for-all. You get to pick any 2 sides you want. So don't overthink it. Look, I'll just circle this one randomly and this one randomly. Again, I just chose those at random. I could have picked these 2 if I wanted to. It doesn't matter. But now that I made my choice and I'm going with opposite and hypotenuse, then this will be my winning trig function that I set up. So here's my setup. Sine, because that's what S is for. Now, I don't know what the angle is. So I'm going to call it A, because that's the one I'm looking for, is equal to a fraction, right? And if you're wondering why I keep bringing all these things up, because I'm using this right here. Sine, A is my angle. Here's my fraction. It's opposite, so 15 over 17. But remember what we said. I'm looking for an angle. This is the only time we ever use this part of our word wall where we're actually going to bring in inverse trigonometry. It says I have to give both sides the trig inverse and not tangent for this one. Because I use sine, I need to give both sides the sine inverse. Because that's what magically cancels out. Inverses magically cancel out the 3 letters, leaving me with the letter A that I want. But of course, this is when we use our calculator here. So when we're using our calculator, let's see, Desmos is ready here. Now, if you use this one, that would be wrong because it's not sine. We're trying to use sine inverse. So remember, you have to press the function button. And there it is. It's got to be the one that has like a little -1. Now I'm going to type in my fraction. So I'm going to go back to main, and it's 15 divided by 17. And so it looks like they want whole numbers. So if it says 61.9, well, look at your answer choices here on the side. 61.9, then 62 is the only one that can be rounded up to get that angle or that answer close to 61.9. But again, you have to know at this point, make sure it's in degree, make sure it says DEG on it so that you're all good. But this is what we type in right here. Okay, moving right along. Now for number 5, this is a throwback. We haven't seen a question like this in a while, but this is just a throwback question. And you have to be careful at what angle they want you to look for. Now, for the example here, we're going to look for two separate angles. I want to find angle Y and I want to find angle X. Again, this is one of those throwback questions. We haven't seen this in a while. But if you remember your past, this is 92. They want me to look for angle X. But remember, when we make this half circle, we're going to bring in the 180 rule. Yeah, we use it for triangles, but we can also use it here because they're making a straight line, and so they're a linear pair. So the idea is x plus 92 is equal to 180. All I have to do is subtract that 92, and x is equal to, well, if I subtract 92, I believe we're looking at 88 as a result. So then we get 88 as an answer for x. Now, on the other hand, when I'm looking for the y over here, well, we actually have a full-on triangle this time, which means if we have a full triangle, well, that's also its own 180 rule that we've seen in the past. So we're going to use the 180 rule again, but in a different format. This time it's y plus 41 plus 92 is equal to 180. And when I combine these two, we would end up with 133 is equal to 180. And we subtract 133, and we're going to get our answer for our problem here already, where y is simply 47. So once again, we're bringing in the 180 rule. Now, if they're next to each other, then that means that we can use the 180 rule like this. But if it's a triangle, well, then add them all up to make 180 as we have before. But that's a throwback question to our past. The other throwback question on the test is going to be very similar to this. I have one angle, two of them. Yes, this one counts. Three of them, four of them. This is not a 180 rule. When you have four angles in a four-sided figure, well, then there's only one rule that can be brought in, and this goes back to a couple of units ago. This one, the four angles add up to 360. So we're using the 360 rule, which means the x plus the 56 plus the 87 and the 141, you have to have four things written out, is going to equal to 360. I'm going to combine these three. So x plus 284 is what they add up to, is equal to 360. And then we simply subtract that 284 from both sides. Doing that, of course, is going to give me a nice round little number. Let's see, we subtract 360 minus 284. See what we get here. All right, we're looking at 76. And there's my answer for x. All right, once again, at this point, you shouldn't be writing, you should just be listening. So let's look at the backside here and see how that goes. Now, this is going to be one of the easier questions on the test, but people tend to do it wrong because they don't understand it. You see, in this question, I asked you, find the measurement of angle A. This does not say find the measurement of angle A. It says, what is tangent of A equal to? We're looking for what tangent of A is. Well, look at what SOHCAHTOA tells us. SOHCAHTOA says, according to our word wall, that tangent of an angle should be a fraction with the opposite on top and the adjacent at the bottom. Well, what you need to understand is that's all we want. We just want a fraction. We don't need anything else. So they said A, then I'm going to mark this one, and now I'm going to label for that one. This is the opposite. This is the adjacent. This is the hypotenuse. And then if you look at what it says here, the opposite is 5. The adjacent is just 12. And just like that, that's it. You're not supposed to solve for A. It doesn't ask us to do that. So please be very careful with this question. They said tangent of A. That's a fraction. This one says measurement of angle A. That's when you do inverse. So please be careful with that on the test. All right, moving right along. Now, there is a question like this one where you are going to need to choose all that apply, And notice, they're already telling you you're missing three sides. Well, then you're going to have to circle three of these together. But one of the things that we notice about these pictures, look, there's a 90 right here. Well, there's a 90 right here also. This one is 28. Well, so is this one. Because I have two angles that are exactly the same measure, then that means these are similar triangles by the angle similarity. And if they're similar, there is a dilation. Again, this is a throwback. Dilation means one triangle is bigger than the other. Well, the only way that happens is through multiplication. So that's our goal. If I want to find the missing sides, I'm going to need a little multiplication to get me there. So here's the thing. First of all, when I look at this picture, they gave me this side. They gave me the 12. All I need was one more. Well, remember, look at that flow chart. If they give you a picture with two sides, I'm going Pythagorean with it. So I'm going to start with Pythagorean. But remember, before you go into the Pythagorean theorem, check your triples. Because if those numbers are on that list, you're going to save a lot of time. In fact, let's see. I have a 5 and a 12. Look at that. Perfect match. That means my third side should be a 13. So I'm going with the Pythagorean triple on this one. 5, 12, 13. And we just found one of the missing sides, which is what they asked for. Notice, I need to find this side, this one, and this one. Those are the three missing sides I'm looking for. Well, I got one of them. And look at that, it's right there. Remember, I'm supposed to pick three answers for this one. But now let's go back to that concept of dilation. Dilation means there was some multiplication that occurred. Well, look, here are the only two numbers I have that actually go with each other. The 5 and the 20 correspond to each other. So the question becomes, what did they multiply the 5 by to get that 20? Well, it had to be a 4. So that means if this is a true dilation and similarity, then it's multiplication by 4 in order for me to find the next numbers. All right, well, look. I also had the 13 earlier, right? Well, then, multiply that 13 by 4. Use a calculator. We have calculators available, the Desmos one. But when I multiply that by 4, I get 52 as an answer. Well, then 52, there it is. Look at that. That's one of my choices. But I still had one more to go, the 12. If this is a 12, well, remember, in order to get this one, I have to go 12 times 4. It's got to be the same 4 for all of them, which makes it 48. And then just like that, we have our three answers for that problem. Okay, moving right along. Again, I just need you to pay attention here. I don't need you writing. I need you focusing on what we're talking about. Now, in number 9 is that problem where they want you to find the distance that the ball traveled, very similar to the one on the test. So you have to find this distance, you have to find this distance, and then you need to add them together. So I need to give them some letters. So I need to find X, and I need to find Y. But if you notice, I basically have two separate problems. So this is a double problem here. So let's think about each side on its own. Now, I do eventually need a total distance. And if I'm going to find a total distance, I will eventually add two numbers to get my answer because I need an X and a Y. I need to find out what they are in order for me to do this problem. So here we go. If this is our baseball player, if I look at this side of the triangle, I was given two sides. Again, if I'm given two sides, I'm going Pythagorean with it. When I look at this side, they only gave me one side and an angle. One side and an angle is an automatic SOHCAHTOA situation. So for this problem on this side, I'm going Pythagorean or Pythagoras, right? So Pythagorean. And this side, I'm going with SOHCAHTOA. All right, let's do one side at a time. Now, when it's Pythagorean, remember, we can save time if it's on that list. So yes, I can use Pythagorean theorem, but let's keep an eye on this thing. Let's see. 512, 512. There it is. We got a triple going here. This side is going to be 13 because they already did the work for us. But remember, if that fails, I go classic Pythagorean instead. So, because this one is a Pythagorean triple, the triple said 5, 12, 13. So this is 13, and that's my first number that I'm going to use for part of my addition. Now, on the other hand, there is no trick for this one. It's a SOHCAHTOA. So here's my angle. This is my opposite, my adjacent, and my hypotenuse. They gave me this number. This is the one I'm looking for. So nothing with the letter O in it, which means CAH is going to be the one that wins, and I'm going to set up for cosine. All right, so here we go. We're going to be setting up a cosine for this one. I have room at the bottom. I'm just going to do it down here. Cosine of, I need an angle, well, that's 51, is equal to a fraction, adjacent 10 over the hypotenuse y. All right, don't need that anymore. We're going to put a 1 under it. And then here we go. The easy one, 10 times 1 is 10. The slightly weird one right there, so that would be y cosine of 51. They're multiplying with each other, so of course that means I still have that extra step where I have to divide by cosine of 51. So I'm going to divide by cosine of 51. And then I let the calculator take over. Just remember, when you're typing this into Desmos, you have to make sure, let's clear that, that you're writing it as a fraction. So 10 divided by, and I don't need inverse, I just need regular cosine this time, 51. And here's my answer. Look at that, 15, not 15.8. It's going to go round up to a 15.9. So we're going to go with 15.9. And there it is. Look, that's the number I'm going to put in here. And now I'm going to bring out the calculator again. I'm going to add these two numbers together. And now I know that the ball traveled 28.9. What was it in feet? That's how long it traveled before it hit that bird. So you see two separate sets. Pythagorean for one side, SOHCAHTOA for the other, and then we add the two numbers together. All right, two more to go. Here we go. And then that way we can get started with the test. So here, they're going to want you to fill out every missing space. And if you notice, I'm missing 1, 2, 3, 4 boxes. So that means this test question is going to be worth 4 points. But look at this freebie point that we're going to give you. Angle C. We already know it's 90. Well, then write that in and get that easy point out of the way. Now, I also want angle A, but I already have the other two. Well, we talked about this before. When I'm dealing with angles and I already have two of them, this is where the 180 rule kicks in. When we're working with the 180 rule, all I have to do is take the 180, subtract the 70, subtract the 90. I got to get both of these out of there. And I get an answer of 20 with my calculator. There you go. We just got another easy point for this test. Now, for the last two, notice I still have two more missing. That's where I'm going to have to bring in our friend SOHCAHTOA into the mix. So this is a lot of SOHCAHTOA here. And if this is the angle I want, well, here comes my labeling. This is the opposite. This is the height, the hypotenuse, which makes this the adjacent. And then this is where people just stop because they go, well, it's because I don't have X and Y. Well, that's because you need to put them in. So for instance, if I say I'm going to solve for X, all right, let's just leave it like that for now. This is what I circle, and I can't circle this one. There's nothing there, so I circle this one. O and H, sine is the winning trig function for that X. So I have some room down here. I'm going to go sine, I need an angle, 70 is equal to a fraction opposite over the hypotenuse, just like the name says. Put the 1 underneath. Here we go. We're going to multiply these two. So that's x equals, and now I'm going to multiply these two with each other. So that's 5 sine of 70. And notice, I don't need to divide here. I'm ready for the calculator. So I'll throw that into Desmos there. And it's going to tell me that the answer for this one is 4.7. If you round off very carefully, 4.7. But now make sure you put it in the right spot, so be careful. X is between the C and the A. Then this is where I would write 4.7. So make sure you're putting it in the right spot. You don't want to lose points after you did the problem correctly. But now we're still missing one more side. Well, look, call it a y then. That means I need the adjacent, and I need to circle one more thing. Well, it has to be this one again. It's the only actual number in my picture, so I get to use it twice. A and H, there it is. We're going with cosine on this one. So cosine of 70 again is equal to a fraction, adjacent, so y, over the hypotenuse, 5 again. And here we go one more time. I'm going to multiply these two together. So that's just y. And then I'm going to multiply these two together. So 5 cosine of 70. And again, look, I don't need division. This one is ready. So I'm going to let the calculator take over. And when I type this in, I'm going to end up with 1.7. And there's my answer, because the y is between the b and the c. So you have to make sure you're putting it in the right spot. Which brings us to the very last problem in our review. Yes, it's a long review, but I want to make sure you're going to do well on this test. So for number 11, very similar to the test, they want me to find these three sides. All right, well, you know what? Let's start off with this one. The only reason I'm starting off here is because I can see a triangle right there. And not just that, they gave me two sides. If they're giving me two sides, that just means one thing. Pythagorean is available for this one. Now, let's hope it's a triple, because if it's a triple, I'm just going to save a bunch of time here. So it's Pythagorean. I'm going to check the triples first. 15 and 17. Look at that. There it is. It is definitely a triple. It's the 8, 15, 17, which means this missing number down here is the 8. So I'm going to put an 8 where the C is, and it's asking for a reason, just like on the test. Look at what I used. I used a Pythagorean triple. Well, then that's what I write down as my answer. Pythagorean triple. Now, okay, that one's done. Now, this number's there, this number's there. I don't need those. But then I'm going to look at this picture right here. And the first thing I spot is the fact that I see a 45-degree angle. All right, we haven't really used this one too much, but here it is. It's a 45, 45. And if you did this correctly in your word wall, these two sides are equal to each other, the ones that touch the 90. Well, here's the 90, so this side should equal this side. Well, if this is 15, well, then this one is 15. So I get to write that in here. And what's my reason? Well, look at the box I'm looking at. This is the 45, 45, 90. Which brings us, of course, to this last missing piece. Well, it's still part of this picture. And notice, if these are equal to each other, it says this is K, then this is the same number, K, whatever it is, with the radical 2 next to it. Well, if that's 15, this is 15, then this is 15 with a radical 2 next to it. And there's my solution for this one, 15 radical 2, because of the 45, 45, 90. And then the last thing it says is you need to find the perimeter of the figure. But be careful. Perimeter means you're putting a fence on the outside. So I'm not going to use these numbers in here. So I'm going to take the 20, added with the 17, added with the 8 that we found, added with that 20 there. Notice I'm just going in order. Added with this 15. And yes, I have to add this one, the 15 radical 2. But what you need to remember from what we've done in the past is this. I'm actually not going to add this 15 radical 2. The only ones I can actually add are these. Since this has a radical attached to it, my answer is actually going to have that 15 radical 2 right there because I can't do anything with it. But I will add these right here. So I'll use the calculator, add it up, and then we get an answer of 80. And then that's it. Again, you do not add that 15 at the end. Okay? All right. So you're about to start the test. Don't forget, no phones out. You get to use the Desmos calculator on the test. Um, Make sure you write everything down on paper. You're going to drop it off right after. You do have an extra credit that can help your grade later on, but take your time, think positively, positive thoughts, and use your word wall. All right. Good luck, everybody.